One of the most interesting and simplest ways to toolpath a job is to use a conic tool or a tapered tool to do a 3D engrave or to do a 3D clean pass on some toolpaths. There's lots of applications for this. This is a pretty simple example, but there's lots of other applications in both woodworking and cabinet making and also in sign making. And so it's a fun way to create really interesting toolpaths. One possible issue with this is that if you get a new tool or if you have a tool that you're not as familiar with, you need to make sure that the angle that you specify for the conic tool is accurate for the tool. And even though it says it's a 90-degree conic or has a 45-degree angle on each side, that may or may not be true. So one of the things that you might need to do is calibrate the tool, which means create some test cuts in order to make sure that you know what the angle is, to make sure that you get nice crisp corners and good results when you create output in EnRoute. So anyway, I'm going to get out of here and I'm going to move over to a simple little file here, and this is one that I'm going to use just as an example of how you might create a calibration file, and then we'll look at some results that I did for a calibration of a tool that not a new tool that I had, but one just to verify that the angle was correct. So if I've got a tool defined, and I most often would start with what the advertised angle, what I think the angle is. So in this case, a 45-degree angle. In this case, we specify half the total angle of the tool. So a 90-degree conic would have a 45-degree angle there. And so if I create a real simple engrave toolpath, and so I'm going to use that tool, and I'm going to create a real simple 3D engrave toolpath. I'll click apply, and so you see the toolpaths that get created. So this is what I would expect to give me a nice sharp corners and to have very accurate outlines both inside and outside, and to make sure that I get really good results. So sometimes when I cut out using a tool like this, if my definition doesn't match the tools, I get some really odd results. So let's look and see what sort of a range of results might be that you could expect for a tool that hadn't been correctly calibrated. To do that, I can go into my tool definition here for a 90-degree conic, and let's change that angle. So in this case, I'm going to make it 40 degrees. So I'm going to make it quite a bit different than what I would expect it to be. And now I can go in and just create the same toolpath using that same tool, but now it has a 40-degree angle instead of a 45-degree angle. So this toolpath was created with that 40-degree tool. Now if I go in and change the definition of that conic again, I'm going to make it 50 degrees. So I'm going to go 5 degrees on the other side of what I think the angle is. And so now if I create an engrave here, so these toolpaths are all very similar. Just glancing at them, it's pretty hard to tell the difference between them, but they actually do have a difference between them as far as what EnRoute used to calculate these toolpaths. So now if I change my tool back to a 45-degree angle, and let's do a quick 3D simulation here. So I'm going to draw a rectangle to simulate, and I'm going to click 3D simulate, and I'm going to go back to no texture there, and for my selected color I'm going to use orange. That's kind of my favorite way of doing it there. And so now if I simulate this, you can see that I get a simulation that gives me kind of a pretty good indication of what the actual engraving would look like if I used the same physical tool for all of these toolpaths. This toolpath was created with an 80-degree total included angle. This one was the 45, so it's a 90-degree angle, and then this one was 50, so it was a 100-degree angle. So that's kind of the range of how far off I might really ever expect to be. But you can see what the toolpaths look like. If EnRoute thought that the toolpath was actually had a smaller angle than what it did, you see that when I go up into the corners, I get this sort of bowing out. And so if EnRoute thought that I had a larger angle, so a little bit flatter tool, then the toolpaths are created, and I end up with sort of this bowing in on the inside. And so that's kind of the results that I might expect to get if I'm on one end of the spectrum or the other. And of course, as I get closer to what the actual tool is, then I get closer to the nice crisp corners that I might expect here. So let's look at a file I created. So this is one that I created that I actually cut out. And so you see what I did is as I wrote the actual assumed angle in here, and this is what I created as far as a range of angles, and gave me a nice range. So if I assume that the tool is a 45-degree angle, I went all the way from 40 up to 51 by 1-degree increments, and then as I got closer to 45 on this top row up here, you see I went in 1/10 of a degree increments as a way for me to really get a sense of what this tool might look like. Now, the one thing that's slightly different with this particular definition that I did, and I'll show you a photograph of my tool, is my tool actually has a slight tip dimension to it, so it doesn't come down exactly to a point. And so what I did is I defined a tool that I called a 90-degree conic taper that had a 0.02 inch or 0.5 millimeter approximately tip on it, and that's the tool that I actually used for defining this to take into account that slight tip diameter in the tool. So that's just a small change, and it's a tapered tool instead of a conic tool, but the effect that I get should be more closely tied to what the actual tool is, because I am taking into account the tip diameter. So if I do a quick simulation of this, so I've got sort of an outline here. If I do a quick simulation of that tool, and let's double check, that tool is defined with in this case, the complete angle that I define, a 90-degree angle. So now if I do a simulation, you'll see that I'll get sort of that range of results like I did in that other simpler file that we looked at. And it's a pretty nice preview of what I might expect to see when I cut out the piece that I cut out. And so you'll see at the one end of the spectrum, the 40-degree angle, I get the thing bowing out, and then as I approach 45 degrees, I get closer to the actual straight outline here that I'm looking for. And you notice, because I do have a tip diameter, it's pretty small, but you can see there is actually a slight radius in the corners, and so that's what I'm going to expect to see when I actually cut my job out. So then as I get up into the higher end of my angles here, you see that the toolpaths bow in. So EnRoute will even do a pretty nice job of giving you a preview of what you might expect in terms of the actual results that you would get, assuming that your tool does have a 45-degree or a total of a 90-degree angle on the inside. So that's my sample piece. So now what I'll do is I'll show some photos of my tool and photos of the piece that I cut out, along with a video of the piece actually cutting on the machine. This is the sample piece that I cut out using a piece of white melamine with a particle board core, and you can see it's a relatively simple piece, but it looks pretty much like the design. And as I zoom in on it, you'll be able to see what the different sections turned out to look like. This is the tool that I used to calibrate, and from this angle you can see that it looks like it pretty much comes to a point. When I rotate the tool by about 90 degrees though, you see that it really does have a tip diameter, and I estimated it at a 0.5 millimeter or about 0.02 inches. A closer look at my sample piece, and I see that I get results that I pretty much predicted. At the low end, you see that the engraving bows out, and then as I move to the high end of the angles, the engraving bows in, which is pretty much what I would have predicted, assuming that the tool has an angle close to 45 degrees. If I look at a bigger distribution here, you can see below 45, I start to home in on a straight cut, and then above 45, I start out at 46 degrees at a pretty straight cut and then work away from that. In the end, when I look at the 45-degree angle, it looks pretty close to what I would have predicted, and so it looks like my tool really does have an angle of very close to 45 degrees, and so that's probably what I would use for my tool definition. Let's take a look at what the job looked like as it was cutting. Thank you, and I hope this is helpful as you work to get your tools dialed in.